Okay, boys and girls, welcome back to Extreme IE. In this video, we are going to talk about Kubernetes architecture. Now, this can kind of be a complex topic to talk about, so I'm going to do my best to keep this video under 15 minutes so that you guys don't fall asleep. But I'm also going to try and explain it in such a way that hopefully it makes sense. Now, you keep hearing me pick on vCenter and keep pick on VMware, and that's because it's honestly the easiest way to explain how the architecture of Kubernetes works. So think about how VMware is architected, where you have vCenter. This is essentially where we interact, and then vCenter communicates down to you all of your physical ESXi servers, and then of course you have your virtual machines that are then created as a result of you interacting with vCenter and saying, hey, I want a new VM. This is very, very similar, almost identical to the architecture of Kubernetes. So within Kubernetes, you're going to have what we call worker nodes. So these worker nodes are going to be where your actual containers live, right? So we'll just say worker node 1, and then we'll say maybe worker node 2 and 3, right? So we'll say that we have 3 worker nodes. Now you could have 10, you could have 100. Now on these worker nodes, these are going to be essentially your VMs, right? So you've built out vCenter, you've built out ESXi, you got your physical server, and then you build this VM, and you're going to make this a worker node. So this is actually going to be your Linux operating system. So this is going to be, you know, Ubuntu, Red Hat, whatever. Now on this worker node is where you're going to actually have to start setting up all of the different services that are required to run your container environment. The first thing that you're going to need is your container engine, which obviously is going to come with your runtime. If you're confused on what they are and what the differences are, definitely go back and watch. I think it's the container basic video or basics of containers where I explain the difference. Essentially, this is what's going to be required for you to actually power on and run the container. This is going to be something like Docker or Containerd or Cryo or a number of different other type of container engines and container runtimes that are out there. The one thing to make sure that it's actually compatible with Kubernetes. I think most of them are today. I don't know all of them. I mean, there's a pretty long list. I don't know all of them, and I don't know all the details of every different container runtime. I think, again, most of them, if not all of them, are compatible, but you know, just double check, right? I might be wrong. There might be one that's not compatible. So just double check when you go to deploy this, and you want to make sure that this is the same across all of your worker nodes, right? You don't want to deploy a different one on each worker node. The next thing that you're going to have is going to be kubelet. Now kubelet is going to be essentially a small agent, and what this agent is going to do is it's going to make sure that each of your containers are running inside of what we call a pod. So what is a pod? Okay. Each container in Kubernetes, so first of all, a pod is the smallest atomic unit that Kubernetes recognizes from essentially a networking perspective, if you will. That's really the best way I can explain it to you. So within this pod, you're going to have a container. So let's just say that each one of these big boxes that I'm drawing is a pod. Inside of each pod, you're going to have a container. Now, typically, you're going to have a container per pod. Each pod is going to have a VNIC connected to it. So think about this for a second. You have your physical server. This physical server is going to have a string of network cards, right? Your physical network cards that connect it back to your switch. You may have a virtual switch, so we'll just put VS in here. You may have a virtual switch that's created inside here as well. And then your VM, meaning this worker node, this guy's going to have a VNIC connected to it. This is what's going to connect him back to, you know, the rest of your network. And then you're going to have these pods, and each pod is going to have its own individual network card, its virtual network card, that's responsible for not only cross communication between pods, but also communicating with this virtual NIC on the operating system, and then essentially going outbound to, you know, the rest of the world. So each one of these pods is almost like its own little segmented area within Kubernetes. So you can, if you really want to, if you run a container per pod, you can say, hey, you know, only, you know, let's say 443 is allowed inbound into this pod. And then if you decide to, you could go ahead and you could create, you know, 3 more containers in this pod, but they would only ever talk inbound 443. Within this pod, they could communicate as much as they want and do whatever they wanted, but with regards to inbound traffic to this pod, they would only be able to communicate via 443. And the same thing would go for a database server. If you connected a database server in here, these three containers, these web containers, would be able to talk to that database server, but nothing else outside of this pod would ever be able to communicate with this database server because you've only allowed port 443. So this is kind of what a pod is. And what the kubelet service does is it ensures that your containers are running in a pod. It makes sure that these containers are put in a pod before they're powered on. Now, the kubelet also makes sure that these pods are working based on your specifications. So you're going to have to configure how you want these things to run and what you want them to do. Again, as I was talking about policies and things like that. And so the kubelet service is what's going to essentially make sure that your pods are healthy and that they're running the way that they should. The last thing that's going to be running on your worker node is going to be kube proxy, and this is what's actually going to be responsible for network communication. Okay, so networking. This is not only what's going to be responsible for your pods communicating to each other, but also how the pods are responsible for. It's also responsible for communicating. Let me say this the right way. It's also responsible for configuring how that pod is going to be able to communicate out to the outside world. So these are the three main services, the three main components, if you will, that are going to run on all three of our worker nodes. Okay, these are the three individual services that are going to run on each worker node. Now, each one of these is going to talk back to a control plane. Now, as a best practice, I always recommend that you keep your control plane separate. I generally don't want to have my control plane mixed up in various different tasks. I always want a machine that's going to act as my Kubernetes control plane. You can scale these out. So you can, you can have more than one. You can scale out the different services in Kubernetes. But again, I generally don't want, I wouldn't put vCenter as a web server doing 18 other things, right? It would be my vCenter server. Same thing with my Kubernetes control plane, okay? Now, all of these different worker nodes are going to talk back to my control plane. Specifically, they are going to talk back to the API server. So each one of these nodes are going to communicate directly back to my Kubernetes API server. And that is also where I am going to talk to. So whenever I want to, or whenever I need to run various different commands, I mean, it's kind of obvious, right? API server. Whenever I need to run various different commands or I need to do various different things, we are all going to communicate back to the Kubernetes API server. But on that control plane, there's going to be various different other services that are going to communicate. So let me just kind of jump into what those are. So first is going to be etcd. Now, etcd is basically a database store. And what this does, there's an S in there, what this does is it essentially, it stores the config data. I don't know why I'm having such a spelling problem right now. It could be it's 1 in the morning, so maybe I'm tired. The config data. It's also going to store the state of your Kubernetes cluster, okay? Now, it also has a monitor or a watch feature built into it where it's going to monitor both of these things. So it's going to monitor the config data, make sure that it's essentially correct. It's also going to monitor the state. So if you have a certain configured state of your cluster, it's going to make sure that that state is essentially correct. So that's what etcd is going to do, okay? Now, as part of the cluster, API is also going to talk to the control manager. Control, we'll just say MNGR for short because I'm lazy. So we'll say control manager. Okay. Now you may, if you go to Kubernetes, if you go out to Google and go to Kubernetes website and you're actually looking at the diagram, this is what's going to be labeled. I think it's CM for control manager. Now, control manager is going to monitor, it's really interesting. So this actually monitors its sub-services, right? So there are various different sub-services of control manager, and control manager as a whole monitors all of those different sub-services, okay? So what are those sub-services? Well, you have the node control. So what the node controller does is this responds when a node goes down. So this is the one that jumps in. I don't even know what I'm trying to say over there. GOES goes down. Then you have the job controller. And what the job controller does is like one-off tasks. So if I have a cleanup task, or I have, just one simple job that I'm running once that I need to essentially have the cluster do, this will spin up a pod, which obviously contains a container, and it'll say, hey, I need something to run these few commands, or I need to run this automated job or whatever, and then it'll go ahead and tear that down. The next one, and please, I hate writing this. It's almost like embarrassing because it's like such a silly name, is the endpoint slice. Do not ask me who made up these names. I have no idea. But what this service actually does is it connects your services. And by the way, I don't expect you guys to like memorize all of this. I'm just trying to get you guys to understand that, the actual architecture of Kubernetes can get a little complex. Not that you guys really need to know this if you're spinning up a cluster, but you may see some of these services as you're spinning up clusters. And if you're on the road to becoming a Kubernetes admin or engineer or architect or something like that, this is probably what you're going to need to know. So this is what's actually responsible for connecting your various different services within your cluster to the actual pods that are going to need them, and essentially making sure that those pods are going to run properly with the proper services and dependencies. Now, the last thing that runs as a subservice to Control Manager is your service accounts, specifically for your namespaces. Okay, JP, what are namespaces? This is why I hate doing some of this sometimes, because you do one thing and it turns into another, a completely different topic. So let me grab my pen again, and we'll do this in a different color. So what are namespaces? So a namespace is basically a way to, what's the best way that I can explain it? To organize various different clusters into smaller subclusters. So if you think about, and I may create a separate video just for namespaces, but if you think about like in vCenter, right, you may have a data center 1 cluster, you may have a data center 2 cluster, you may have a QA cluster, and these various different clusters are running various different applications. Well, namespaces are basically like that, where they're separate clusters, and so instead of having one giant cluster that runs all of your applications, your namespaces are a way to actually break those out into various different subclusters, where you can almost run an application in a single cluster. So it's just a way to organize that a little bit better. Let me go back to that view. There we go. Sorry about that. We'll go back to white. Okay, so where were we? So yeah, so that's Control Manager. Another component that we're going to talk to is called the Cloud Control Manager, MNGR. This is going to be abbreviated as C-C-M. Now, this guy here is essentially going to be, let me draw some boxes around here so you don't get really super confused. There's one more service, but we'll draw it out here. The Cloud Controller Manager is what's actually going to be, it's actually going to communicate out to your cloud provider. So we'll say cloud provider, okay? So if you have a cluster that spans into your AWS or something like that, if you're actually managing a Kubernetes cluster that spans out into the cloud, this controller service is what's actually going to go in and manage that. Now, just like the control manager, there are various different services in your cloud control manager that are responsible for different things. So you have the node controller. Is what actually goes out to your cloud provider and collects various different information about your cloud provider, as well as any updates to your cluster. So let's just say that I have worker nodes out in the cloud. So we have worker node 4 and worker node 5, right? What will happen is this service will go out and collect various different pieces of information about those worker nodes, and then update the rest of our cluster with the information of those worker nodes. Okay. Then you have the route controller. This is pretty straightforward. It's responsible for making sure that if you have a container or a pod here on this worker node and it needs to reach the worker node out here, the route controller is the one essentially responsible for making sure that that routing and reachability takes place, okay? And then the last thing is your service node. This guy is going to be responsible for connecting to various different services within your cloud provider, or I should say not within your cloud provider. I'm not talking about SaaS, but like configuring load balancers within your worker nodes in your cloud provider. So this service is what's going to be interacting with that. Now, the very last service, and again, I'm gonna, maybe I'll draw it here, is going to be your scheduler. Now, the scheduler service is going to actually be what monitors your cluster and your pods. So the scheduler service, so going back to here, going back to how every single container gets spun up into a pod, you can specify what pod you want your container to be in. So if this is like pod number 1, for example, and I want my new containers to be spun up within that pod, I can go ahead and I can configure that. What the scheduler service does is that if I go and I spin up a container and I haven't specified what worker node or what pod I want it on, then the worker node itself will go ahead and it will go ahead and look at the resources across my worker nodes, and it will assign it a new pod, and it will go ahead and put it into the appropriate node that it should be put on, right? So I don't have to go and I don't have to pick that myself. Same thing in vCenter, where you would right click and say, hey, I need a new VM, and you might go pick a particular node or a particular ESXi server, but you may get some recommendations to put it somewhere else. Well, that's what the scheduler service does. It kind of is responsible for making sure that those new containers that are spun up, or I should say those new pods that are spun up, are put onto the right worker nodes. So again, I hope this video wasn't too complex for you. I hope it kind of outlined all the different services that Kubernetes uses to make life possible for you. I will see you guys in the next video.